we can record it. So sine square t, remember always that it's the t I, the one in the previous step, q over a ti minus ti plus 1 minus ti. When you are working with the calculators, please make sure that you work in radians. If you work in degrees, you are going to get errors. So this becomes 0 plus 3 into 450 divided by 1250, 1.08 sine square 0 is 0 minus 450 over so it comes out to be minus 0.36 into 0.5, 0.18. So that's the first value. We get y as minus 0.18. Again, remember, y is at the y is 0 at the center of the tank. So minus 0.18 means it has fallen below the middle of the tank. If you get a positive value, it means it has gone up because the outlet is q is at a constant rate. The inlet is a sinusoidal wave, so it may have fluctuations go up and down from the center. Okay, please try to complete it. If you want to use calculator, you can use calculator. If you want to do it by Excel, you can do it by Excel as well. If you have any issues, please, you can check with me, but I want you to be solving it so that you know how to work with the problem. Okay, please start working. If you want to see this, I'll keep this here for you to see it. Now I can do the two things together. How many times do we repeat the equation? If you are going to go to according to the question, it says from 0 to 10. So 10, let's say 20 times, because you are going step of half, so I have to repeat it 20 times. Therefore, if you use Excel, it will be faster for you. If you can share the results, then it's good, so that we can compare the answers. I'm waiting for the numbers, please.
Doctor,
Yes.
I found it at time 10. It will be 1.6543.
1.6543. Not exactly what I get. Minus 0.3599. No.
Doctor,
Yeah.
I think it is going to be 1.4944, I think.
Yeah.
Oh.
At 1, I found it to be minus 0.23588. At 1.5, That's according to Excel what I have found. If you are going to use the calculator, please, as I told you, make sure you are working with radians, not with degrees. When you finish, just write there that you are finished, so at least I know that you are doing something. At least I know how many of you are finishing. Okay, Omar has finished. Yeah, these full days. So you see the number is 450 meter cubes per day. 450 meter cubes is not a small amount, it is a very big amount. Yeah, that's right. So let's say almost 1.5 meters. Because if you look at the area of the tank, it's huge. It's 1,250 square meters. Uh, which formula?
Doctor, in question 1.10, this dy by dt equal to 3q over a sine square t minus alpha bracket 1 plus y raised to power 1.5 over a.
No, he's telling you that in the previous question that we have seen, we said that the outlet, which is Q, is constant. But now he's saying that, let's say the outlet is not constant, but it also depends on the depth. And then for that case, he's giving this equation. And
So,
just like
Doctor,
he gave you
yes,
the equation for the inlet as 3q or 3q sine square t, same way he's telling you that the outlet is based on an equation like this.
so they are going to give us the equation. We don't have to find it, right?
Yeah, you don't need to find it.
Okay.
No one else finished? You are taking very long time like this. Girls, boys, did you at least find this and this? Why not? I showed you at least one step. You just need to change the values, just like we have done. There is nothing to be done. Uh, just like we did this now. Then the next step, at t equal to 1, you will say y at t equal to 1 is y at t equal to 0.5 plus 3 times 450 over 1250 sine square of t equal to 0.5 minus 450 over 1250 divided by now 1 minus 0.5. So it will be minus 0.18 plus 3 times 450 over 1250 sine square 0.5 1.08 multiplied by sine of 0.5 0.2298 minus 0.36 into 0.5. Yes, that is why you need to practice by yourself. If you just keep relying on me to find the answers, then there is nothing in these equations. But if I'm doing the calculations, you are not getting the practice of doing the calculations by yourself. Otherwise, the equations have nothing very special in them. Can I do it on the Excel? Yes, I can do it on Excel. The question is not if I can do it on Excel. Can you do it on Excel? You should ask yourself. I can do it on Excel. Is no problem in me doing it on Excel. Okay, I'll put it here. This is our equation. I'll put the Q and the A values here. The Q is 450, area is 1250. The T and the Y. When the time is 0, this is 0. This is previous time plus 0.5. This is YTI plus 1 is YTI plus 3 multiplied by Q divided by A multiplied by sine of T square minus Q over A multiplied by this time minus the previous time. Both of them in a bracket. I'll just correct this is or maybe I'll correct it here. I put here the y value is supposed to be the time value. We need to go up to time 10. So there you have it. If you want to plot it, we see that that is how the level is changing. It seems ultimately it is increasing with time. The level is going up and down, but with time it is increasing. Any questions for anyone who doesn't understand? Okay, let's just look at another problem. Maybe a bit simpler one. Problem 117. It says Newton's law of cooling says the temperature of a body changes according to this equation. dT over dt is minus kT minus TA, where T is the temperature of the body, T is the time, K is the proportionality constant per minute, and TA is the ambient temperature. Suppose that a cup of coffee originally has a temperature of 70 degrees Celsius. The ambient temperature is given to us as 20 degrees Celsius. K is 0.019 per minute. We want from 0 to 20 minutes using step of 2 minutes. And originally the cup of coffee is 70 degrees Celsius. We want to see after 20 degrees Celsius what's the temperature of the cup of coffee. It's very simple and straightforward. Try to find at least you are starting from 0 with steps of 2. So you'll have time and temperature. At 0 is 70. Then 2, 4, 6, 8, you need to go up to 20. T2 68.1, yes. T2 is 68.1. Uh, 66.27. Hassan, 64.3 is what? 40 equal to 6. 64, I got it. 64.5. Maybe it's just the rounding off of the numbers that you're doing.
Doctor, at 20 minutes, it will be 53.94.
Yeah. So 68.1, then 66.2722 at 6. I found it 64.51386 at 8, 62.82 at 20, 53.94. Yes, 53.94. Then not 54.93, 53.94. Yes, that is right. If you want to compare, let's say, I'll make a new sheet here, that we have dt over t dt over dt is minus k t minus ta. Yeah. Now, if I want to do an analytical one, it will be dt over t minus ta is equal to minus k dt. Then I can integrate both sides. I'll get ln t minus ta is equal to minus kt plus a constant. Just to make life easy for me, I'll write it as ln c. Now at time equal to 0, temperature is 70, so len 70 minus ambient is 20 is equal to minus k times 0, that will be 0, plus len c. So len 50 is equal to len c, so I say c is 50 degrees Celsius. I could put it back in the equation, so len T minus TA equal to minus KT plus len 50. I'll take the len 50 to the other side, so I'll get len T minus TA over 50, because minus len, this minus len 50 will become divided, minus KT. I'll take exponent on both sides, so I'll get T minus TA over 50 is exponent minus KT. I'll take 50 there and the TA there, so I'll get TA is equal to TA plus 50 exponent minus KT. That's the analytical solution. T is 54.193. Yeah, that's the analytical one. Yeah, right. So I'll make here the time. I'll take the T analytical and I'll take the T numerical. The analytical is not required. We are just doing it to compare. At time 0, this is 70, this is 70. At time 2, this is, we said, the ambient plus 50 multiplied by exponent of minus k 0.019 multiplied by time. The numerical is the old value plus minus 0.019 multiplied by the old temperature minus ambient multiplied by the step size, which is 2. And I have 4, 6, 8, and of course I can copy it down, make it faster for me. So those are the values I get. I can plot them to compare them. So we can see that they are almost similar values. I'll just change the range of the axis to go from 50 to 70. So we can see the difference there is not very big, just a small difference between the two values that we get, as we can see here. Just a difference of 0.25 Celsius. That's all that we have as the difference between the two values. So something simple like this is good enough, what we are asking for. Something complicated like a question like this is not what we'll be asking. 1.8 is a simple one. You could expect something like that. 115 is a bit of complicated question. We are not expecting to ask questions like this because there's a little bit of complication involved in those questions. So we expect something easy, not something very difficult in the course. So You can try them, of course, see this if you can work with the problems, but generally we are not working with such difficult problems. We try to work with something simple, because this is just the introduction chapter. We don't want to have something very complicated in this chapter. Okay, we'll stop here. Any questions? But please do try to solve by yourself. If I solve things for you and you don't practice by yourself, you're not going to learn anything.